Hi guys, welcome to the channel Learn with W3 Schools. Today we're going to hack into Java OOP in 20 minutes. We're going to learn Java OOP's basic fundamental concepts in a standard direct code approach that we will go through each of the code syntax and learn them within 20 minutes. I'm Dr. Zeeshan. Let's begin. Now, in order to create a class, we know that we have to use public class and the class name. Every standard Java code has this. Then we create data types. Now, what this means, this is a class variable. Now, this variable belongs to the class body. Okay, and this becomes a part of a class. When we create an object of this class, we can use this method directly. Then if you create an object of a class, in order to do that, so for example, if I have class called my channel, I can have a public static void main, and inside this class I create learn with W3 schools. Now this is the creating object of my first class. So I had a first class known as learn with W3 schools. I just created a variable inside this class. So I create another class, create an object by declaring the class name, the variable name, or as it now known as object name. The new keyword defines that we are creating a new object, and now we are calling a constructor. Talk about this later. Constructor basically means that it's a default method that exists inside it. So this will create a simple object within it. Now once we have an object, this object now represents all the data that exists inside this particular class. So my object can access this .x variable which is here. So we use my object .x and we use it inside system.out.println. So it's going to print this value inside our println method, outputting the 5 answer. Object dot is basically a connection operator that connects this object with this variable name. You can create multiple objects of the same class. So we have learn with W3 schools, object 1, new, learn. So this is creating second object, this is creating third object. Do keep in mind that in an object-oriented principle, every object has an independent copy of its class data. Hence, I have a separate class. Inside a separate class, I'm creating an object of my previous class. I can do that. Second, I can create multiple objects. Each object will have a separate entity of its data. So object 1 will have a separate copy, object 2 will have a separate copy. Let's explore this example more in detail. So for example, we have Java class attributes. We say we have integer x, integer y, and string name. Within public static void main, we create learn with W3 schools object. Now again, this class is there. I'm creating object within the same class. Previously, we created in a different class. So we can declare two different classes, create object of one class in another, perfectly okay. You can save those classes in the same file and save them in a separate file as well. Now here we create an object and we can change the value of that object as well. So we have my object, which is again new and using the same class name with parentheses. This is known as a constructor call. Now I go object.x is equals to 40. So whatever the value of this class object is, I've changed it. And then in order to print it again, I use object dot operator x. So use the object dot operator and access the data of that class. Then you can create multiple objects as well, again with the same mechanism. So we create the same object of using the same class name, but within the same method. However, every object will have its independent copy. Now if you go and change the value of x using object 2, so this becomes 25. Previously it was 5, we changed it to 40 using object. Now we created object 2 and we changed it to 25. But when we go and print it, the object 1, this one will still print 5, even though this obj has already changed it to 40. And then if you see object 2 will have 25. So why the values are not being changed? Because every object has an independent copy of its class data. That's what we are trying to understand here. So when we use this basically means that every object will have independent copy and it will not affect the other objects. So if you change the value using one object, the second object will have no effect on it. It will not be notified, it will not be changed, everything can be done there. So this is how object relation works within our system. Now let's talk more about Java class methods. We have been using public static void main. It's a type of method that is invoked by default by the JVM, by the JVM or JRE as we call them, is basically responsible for executing this method. But you can create your own custom methods. To do that, you will use signature called void, which is a return type, and we use something called a method name. Now you can use any method name as long as it does not start with this number, does not have a space, or is not a keyword. So void is a return type, my method name, bracket start, bracket close, block start, block close, and then any set of instructions you process here. Methods are known as set of instructions that perform a specific task. So we use methods for a reusability, so that certain code that we want to process again and again, instead of writing them, we write inside a method, and now I just need to call a method. So this also is known as a method declaration, means we have declared a method. Declaration means that method will not execute until you call that method. So we are just defining that if the method is executed, it will perform this set of instructions. To call a method, we go and use my method, bracket star, bracket close, semicolon. So we use the same method name, bracket star, bracket close, and semicolon. This is called a method call. To call a method, you can call a method inside another method. Do remember that a method can only be called inside another method, which in this case is main method, or you can declare another custom method and call that method inside it. But method are declared outside of methods inside a class body. So this method is declared inside the class body. It cannot be declared inside main, or we cannot declare another method inside this method. So they are independent copies inside our class. Let's talk about why we use those static here. Now static defines that if I create an static, I do not need to create an object of this class to use it. I can directly call this method. Previously, in order to use the x variable, we had created an object and then used that object dot operator and the value. But by specifying it as a static, I no longer need to create an object and use an object of this class to access this method. I can do that, but I don't need to. I can now directly call this method without even creating an object. That's what static does for us. Okay. And then once we set it to a static, we need to ensure that we make it public as well at certain times. So for example, here my method is declared as public. So we can access this method outside of the class as well. Public is an access modifier. It defines that your class data, class method can be used outside of the class as well. Means you can declare other classes outside, separate classes, and call these methods there. So we have a static void static method, system.out.println. We have a public void public method. The difference key is that the static method can be called directly without creating the object. But if you try to do the same with the public method, which is only public, not static, this would generate an error. So in order to use this public method, we would have to create an object of that class. So we here created a learns with W3 schools again, the name of the class that we declared here. We create an object, new, and then again same class name with parentheses. This is known as a constructor. New will create a new object, assign it to this variable, and then using this variable, we use the dot operator to connect and access the method of this class. Because this is public, we have to create an object. Because this is static, we don't need to create an object. However, we can, and we can use this object here. If it is static, the same object data or the method data will actually be shared between multiple objects. Now this is where we need to be very careful of. So if you declare a data type as static, that static data will have a shared copy among different objects. So access methods with an object. So how do we access method with an object? So for example, we create a void main full throttle. Okay, another method, we define certain properties for that method. Whatever code you write inside this method is a standard Java code. We create another method called speed. This time this method takes an argument, or what we call a parameter. Means that when I execute this method, I need to provide it some value before this method can actually perform its functions. How do we use these two functions? We come here, we create variable, object, learn with W3 schools, we provide the variable name, new period. So every time you create an object, use the class name, whatever the class name you have specified. So in this case, the class name is learn with W3 schools. We use that. Then we use for a very object name, which is my car in this case. So my car dot full throttle means I'm calling this full throttle method. My car dot speed is there. Now what I've done here is I've passed it an argument. I passed it a value 200. This value will be assigned to this variable here, which in case then can be used inside this method. This variable is known as a local variable. It can only be used inside this method. This max speed variable cannot be used outside the method. So we can only use it inside this method. Then we pass this value to this method and we can use it. So this is called passing value to a method, or passing argument, or passing parameter. Okay, so this actually is a parameter. This is what we call an argument. Means in terms of syntax, in declaration we have provided, hey, this method needs one argument, and we are passing it a parameter 200, which will be assigned to this argument. So this is how we use these methods to specify various different values. Then let's talk about something called multiple classes. You can declare multiple classes in Java. I already shown an example earlier. So we say we have a class second, which again means that we have a class learn with W3 schools. We have already created this previously. So now I create another class called second. Inside this second, I declare another method called my method. Inside this method, now I'm declaring an object of my first class. These two classes can be in the same file like I have right now, but typically we save them separately in two separate files, each file name having the same name as the class name. So when we compile both the files and then we execute. So now when we execute this, my method, when I call this method, it will create an object of learn with W3 school class using under my car object. And then now I can use this object to access the method of this class. So this is how object oriented works. We define everything inside a class, methods and data. Then we create an object of that class, and then using that object with a dot operator, we access the method and we process the data of that method. So this is what we're doing. So now we are accessing the methods of a class A inside a class B by again creating an object. Okay, now let's talk more about this constructor thing that we have been talking about. Every class by default has a constructor, even though if you have not declared it. The syntax of constructor is that we provide something called public, no return type, and learn with W3 schools, same name as the class name. Every method that we have something called void, which means a return type, meaning that this method when executes will return a value. I've talked about this in my previous videos, link is in description, check it out. So now here what the constructor means, that this is a type of method, but it's only executed once every time you create an object. So whenever you create an object, this constructor is automatically called and it initializes the object. That's how we define it. So a constructor is used to initialize an object with some values, and that of initialization actually is done at the back end. Here we have just overridden that method and provided it our own customization. So we say, hey, there's a class variable called x, and I want to initialize this value is equals to 5 inside a constructor. So when a constructor is executed, it will automatically call this. Keep a keen eye on its syntax. The constructor don't have a return type, and the name of constructor must be same as the class name. Third, the constructor always gets executed when we create an object of that class. Fourth, constructor only gets executed once the object is created. Next time you cannot execute it. Every time you create an object, you can call that the constructor is called. Okay, you can basically call the constructor by creating an object. For every object, again, the constructor is separate. Then you can have overloaded constructors as well. Overloaded constructor means having the same name but different number of arguments. So in this case, I have a constructor that takes argument called string Dr. Zeeshan, my name. So here we have a simple constructor that is having no arguments, but we can create a same constructor, public, no return type, learn with W3 schools, and we provided an argument called string n. Means when I need to create an object, I pass it a certain value. I need to pass it a certain value. And then we can use this n value that we have passed and change the value of the name variable which we have declared inside the class object. So hence, every time a user creates an object, they need to provide the argument value. Okay, that it will be in a string form because the syntax we have declared that this constructor will take a string form. The default constructor is without any argument, which again exists by default if you do not specify it manually yourself. Understand? Perfect. Let's talk about multiple parameters. You can pass multiple parameters within the constructor as well, not only one argument. So you can have one argument, you can have multiple arguments as well. Just be careful that whenever you create an object of this class, you then again need to pass the same number of arguments and the same number of sequence. So now if I have learned with W3 schools, object, new, I call the constructor. This time I pass it argument called Dr. Zeeshan and my channel name learn with W3 schools. This means that I need to pass two arguments. So when I pass it two arguments, automatically Java compiler and Java's JVM will execute this constructor. If I pass it only one argument, it will automatically execute this constructor. If I pass it no argument, it will automatically call the default constructor. That's how the system works. So we use certain code inside the customer that we only want to execute one time, that can initialize or do certain tasks only one time when the object is created. Okay, so wherever we want to create an object, only certain piece of code needs to execute, and we put it there. Let's talk about a little bit more about modifiers. We just did about public. The code is accessible for all classes, meaning if anything is set as public, all classes within the same class or outside, if you are using multiple classes, they can easily access and use these methods. Private, the code is only accessible within the declared class. So if you set it private, it can only be accessed within the declared class. So if I set it to private, a method can be set to a private, means now with this method cannot be used in another class. Okay, by default we have default. So if you don't specify anything, this is a default modifier. So it is no longer needed to write the word default because it is already there. The code is accessible only in the same package. So if you are declaring a package, means the same folder. So as long as your code is inside the same folder, it can be accessed. Otherwise it cannot. If you set it to protected, the code is accessible in the same package and the subclasses. So if your code can be accessed in the package as well as in the subclass. More examples for these later on. Now let's talk about Java encapsulation. Java encapsulation is to make sure that the sensitive data is hidden from the user. It's not exactly a syntax wise, it's a way of coding, and it's a most common way of coding Java in form of OOP. What happens is that we provide certain methods to access and change the data. In previous examples, we changed and access the data directly. By data meaning data that has been declared inside the class body directly, not inside the method, inside the class body. So this integer x, string name, channel name, this is what the data here represents. Here, when I call this x, I'm directly accessing the data. Encapsulation means you should not be directly able to access it. It's not healthy, not appropriate. Similarly, I'm accessing the data directly to print the name here. Okay, so I'm accessing the data directly here to printing the name and the channel name. So in order to avoid this and in order to provide more security and ensure that our code is more secure, we use something called encapsulation to hide the data directly and use methods to show certain data. This is where our access modifiers also come into play. So for example, if I have a class called public person, okay, so this is my class name. Here I've set it to private name here. Now private, again, if you remember, means the code is only accessible within the declared class. Now this variable cannot be used outside of this class. Even though if we create an object, I still cannot use it because the access has been restricted. So it can only be used inside this class. Then we set a public method. Now this is what we do in terms of encapsulation. We use a methods called get and set. Again, these are just names, custom names. You can write whatever names you want. Okay, there's no specific to this, but the idea here is that if I need to read the data from the class, I use a method with starting with get, and if I need to change some data of the class, I use the method called set. So in this case, I have a string name. Now if I need to update or change the value, I need to use the method called set. So public, again this time it has been made public, so this method can be accessed by objects outside of a class. Return type, it doesn't need to return. Now I use the word set. Again, this is not necessary you use the set word. You can name it what the hell ever you want, but it's just main common standard practice. A good programmer follows a standard convention. So the convention is that you use name called set name, which means that in a programming standard you are updating or changing the value. What value you want to change, you would use string new name, and then you say this dot name. Now this is used here to refer to the data of my same class. It's a keyword reserve word. It has an implication that I'm referring to a variable called name that actually belongs to my class. So this means I'm referring to this name. It's like an implicit object of your own class is equals to new name, which is again passed as an argument when the method is called. Hence, now in order to set the value of this, I have to use this method. So I cannot access this data directly. And then to read the data, I would use a method called get name, which will return this name for me. So now I have a return type called string. Previously, we've been using void. So here return means that when this method executes, it's going to return a value in form of a string to me. I said, okay, no problem. How do we use it? So we create public static void main. We create an object of person class, object person, new person, bracket start, bracket close. Then we say, hey, object, set name. So first we need to set the name. We set the name to John. Okay, so now what it will do, it will call this method, pass the argument value here, and this will update this variable data. Because I can use name within the same class, I've used this signature, this method, to change this value. Rather than directly using the object name dot name, this will generate an error for me. So if I use object name dot is equals to John, typically in previous examples we did that, but now I cannot, because this name variable is set as private, so it has a restriction. So in order to change its value, I have to use this method called setName. Then to read the data, hey, what's the data? I changed it, now can I print it? I again will need to use object dot get name method. So this get name method will return a name using this signature here. So we are calling this get name method. It says return a reply of this name variable I here. Now notice I have not used this here. You can use this here as well, no problem with that. Okay, but if you, in certain cases you don't need to do that. So because by default it will mean I'm using the data of my class, but it's always a good practice to use this. Okay, as a good programmer, as a good convention, it's always a good practice to use that. So now we're saying, hey, this dot name, meaning that I'm referring to the variable that belongs to this current class. So this is again referring to my current class. So it will return the value here in form of string. Because this will return a string, I can directly print this string inside system.out.println. Capish? Excellent. Now let's move on to and talk about something called Java inheritance. What do we mean by inheritance? Inheritance means inheriting the property of parent class into a child class. It's what we call the parent-child relation. So if you are a parent, means you have certain properties. Then once you have a child of it, the child will inherit the properties of a parent. Let me show you an example. So we say we have a class vehicle. We create protected string brand Ford. Now this time it's protected. Again, by protected we mean that this code is accessible in the same package. Package means folder. So as long as my both classes are inside the same folder, this code will be accessible. Okay, so this protected code will be accessible. If it's in different package, in other words, a different folders, now it cannot be accessed. So we say protected string brand is equals to Ford. So we declare a variable. Then we say public void honk, and then we set certain method here. Okay, so this again set of instructions we process. So this vehicle class contains two things, one data and one method. That's what basically every class is able to contain. We provide data and we provide method. Then when I need to do inheritance, what I do is I create a brand new class. I give it a class name, for example, car, and I use a keyword called extends. And then I use the class name I want to inherit, or my parent class name. This extend keywords is a powerful word that defines that I'm inheriting all the properties of my vehicle class and giving them to the car. It's just like signing off a will that all that belongs to vehicle is now part of the car. So all the data that is part of vehicle is actually now has become part of car. So I can use this data inside my child. This is what inheritance does. This is simply it is. So all the properties, data and method of my parent actually have been included and have become part of my child class because I've given it a permission using extends vehicle. So we say we again have something called private string name Mustang. We create public static void main. Inside this we create an object of car, my car, new car. So we have an object, no problem, fantastic. And we say car honk. Now if you notice, there's no honk method in this class. Okay, the class ends here. The honk method actually exists in the parent class. But when we did the inheritance, the parent data is being inherited inside the child class. So the child now can access honk. So by creating the object of child, I'm accessing the method of my parent because it's already been inherited to me through the will of extents. Simple as that. Okay, this is what our inheritance looks like. So once we do inherit, everything is accessible. Let's talk about something called final keyword. The final keyword plays an important part. This allows us to stop the inheritance. So for example, you want a class and you said, hey, I have something specific inside it. I don't want to inherit anything and I want to cut off everybody from this will. And I want to ensure that nobody does the inheritance. So we set it as a final. Typically, we use final in front of variables to ensure that the variable value cannot be changed. We use very final in front of the methods as well to restrict the methods over properties as well. And if you use the final keyword in front of a class, now we are specifying, hey, listen, I have a class and I don't want it to inherit. So I have a class extends vehicle. So if you try to do this thing, try to extend this vehicle class and inherit its properties, when you run the code, it will give us an error. You cannot inherit from final variable vehicle because boss, this is final, you cannot change it. So Java has that encapsulation, has that security that you can use to hide certain data by using modifiers, by using something called final that will restrict certain ways. Okay, let's talk about something called polymorphism. Now, polymorphism means having same method name in different classes. Okay, same method name, same signature, and uh, extended into different classes. This typically is also known as method overriding. Polymorph means many, morphism means shapes. So means many shapes exist having same name, same signature. There is something called overloading as well. We talked about this in detail in one of the method lesson of Java. Okay, in that methods we have been discussing, and I will again share with the details as well. Overloading basically means that we have same name but the number of arguments differ. That's a different thing. Overriding means having same name throughout your classes, having same number of arguments. So that's where the different shapes come into play. Let me explain. For example, we have called class animal, and then we say animal sounds, no arguments in this case, and we create a block of code that performs a specific task. Then we create another class called lion. Said okay, perfect. This time we extend the animal class. Said okay, we extend it. That means we have inherited all the properties of animal. So by definition, this method has been inherited and is now part of this class. But what if I want to use the same name but have a different function? So what we do is we override it. This is called polymorphism. So we use public void animal sound, the same class name, bracket star bracket close, same signature, because it does not contain argument. Here is no argument. If I change the argument, now it's not overriding, it's called overloading. Okay, so if you use, for example, integer x here, now it's not overriding principle, it's an overloading principle, because now animal sound, this method will also exist, and animal sound integer, this will also exist. So both methods now can be used without argument and with argument. This is overloading. But if I change the argument and make sure the signature is exactly the same, now it's overriding. Means we have overridden the default, the parent method's functionality, and we have provided our own functionality. Something my parent class has, but I don't like it, but I want to use the same method. So we override it and we change the functionality. Then I have another class called dog, again extending the animal, the parent animal. So we have two child. So this parent has two child. Again, keeping in mind, yes, a class can be extended by more than one class. So this animal class here, lion has extended it, dog has extended it. But at any given time, you can only extend one class. This is said that Java does not support multiple inheritance. This is why, because multiple inheritance means having multiple parents. That's not allowed. At any given time, you can only have one parent. Okay, but then there's something called interfaces, and you can do multiple interfaces. Talk about that later. So now what we've done is, again, we have overridden this method and provided different functionality, different for lion, different for dog, and different for the actual parent. So when we create an object, this is what, look at what we've done now is, we create the object using the parent, my animal one. This is again legal, and we create animal, new animal, and then once I use my animal sound, it's going to print the my animal sound. So I've just directly created an object of animal class, no problem, perfect. It's going to call this method. But then if I go and create an object of a lion class, it's going to come here and it's going to say, hey, lion animal sound, is going to print the animal sound of a lion class, which again exists in the parent class, but it has now been overridden by the lion class. Then if I create a dog class, it's going to again call the object of this, and then when we say dog.animal sound, it's going to make and execute this sound here that's been declared inside the dog class. So we have animal sound, animal sound, animal sound, but every time the object is different, the functionality is different. because we have overridden this thing. So this is what polymorphism means: having same method name, same number of arguments in your inherited classes. So when we inherit our class, we override our parent class method. This is overriding. Okay. Now let's talk about inner classes. So inner classes means like creating a class within a class. So we have a class called outer, then we have called class inner. Means that I have a parent class and I have a child class, but this time the child class is inside my parent class. This is completely different from inheritance. Inheritance means I have a two separate files, two separate entities. One entity is a child of another. Okay, and inheriting the content of parent class inside the child. However, when we create inner classes, now they are not extending it. This is not inheritance, it is what we called the nested classes. So this class is inside this class. How do we use it? The usability again differs. So we say to access the inner class, we must create the object of an outer class first. You cannot directly access an inner class. In order to access this inner class, you first need the object of an outer class. So we come here, we create an object of outer class, object new outer class. Then we say now using this outer class object, I will be able to access the inner class. So to create the inner class, we use, hey, listen, outer class dot inner class. Okay, my inner, and we're gonna say, listen, my outer. Now we use this object dot new, create a new object of this inner class method. Okay, so we are saying that, hey, there's an outer class, go inside it, there's an inner class. So we are accessing the inner class with reference to outer class, providing it a variable name, then using the object of an outer class with the dot new operator. And now we are using the constructor of inner class. So this time the inner will have the access to this value y, my inner value y, meaning that I'm accessing the data of this inner class. And I can still use outer dot x to access the data that's inside the outer class. This is what exactly happens when we use system.out. So system is outer class. Inside this outer class, there's an inner class.out. Inside this inner class, there's a method called println. So this is another way of encapsulation in which we try to hide the data inside different classes, and we make sure that you use the hierarchy to access the data. Okay. Then let's talk about private inner classes. So if you declare a private class as private, now this cannot be accessed outside of the class. So if you use the private keyword again, as per private definition, this class now becomes completely private. If you come here, you cannot use it. If you create object, it will give an error to us. Okay, so again, another way of encapsulation where we have an inner class data that performs certain tasks, but we ensure that you cannot create an object of inner class and it cannot be accessed outside and without object. Okay, let's talk about something called static inner classes. Now you can declare your class as static, the inner class. If you do that, that means that now you can, as per definition of the static, again, you can access the inner class without creating the object of outer class. Previously, we need to create an object of outer class first in order to access the inner class. Okay, but if I set it to static, this means that this is static, and now in order to use it outside the class, I don't need to create an object of outer class. The way we do it is that now directly use outer dot inner class. So we still need to use this outer dot inner class. So I'm saying, hey, outer class, inside this outer class there's an inner class. We use it, give it an object name, and see there's now no object needed. I just simply use new outer class dot inner class again. So the syntax varies. So if you set it to static, now you can directly access it without having the need to create an object of outer class. So in this case, when we use system.out.println, basically we have system class. Inside the system class, we have a static outer class. Inside the static outer class, we have a static method called println. That is why we are able to access this directly without creating an object. So println is a static method in a static inner class that belongs to a system class. So we are directly accessing it without creating an object. So static is quite powerful. It eliminates the need of creating an object, but beware, it has certain issues and limitations as well. Means the data shared by objects data will be shared by objects as well. Okay, let's talk a little bit more about Java abstraction. Now there are two things in form of abstractions that we can do, called abstract classes and interface classes. Okay, so very quickly let me go inside this and talk about them. Java abstraction is a way of hiding certain details and showing only essential information to the user. So an abstract class and an abstract method both are used in an abstract class. Simply speaking, an abstract class is basically like a prototype. You do not provide the entire information. You just create a syntax of structure, a prototype, that what needs to be done in this class. And the actual definition is provided in a separate class. That's a key concept within OOP that we use, or in an advanced Java concept that we have. Okay, so we say, hey, this class is abstract because it contains something called an abstract method. It can contain the regular method as well. So normal method exists, no problem. But the abstract method can only be declared inside an abstract class. So this method can only be declared in here. It does not have a body. Note there's no block of code, there's semicolon here. Because the body is provided by the subclass or the class that's going to inherit this class. So we just provide a declaration. It has its aspects, it has its uses. So this is called method declaration only, or in a simple term, abstraction, because we use this as a method declaration syntax as well. So we say that, hey, because these are method declarations, okay, these are method declaration. To use this method, we do a method call here. This is a method call. In abstraction, we don't use the word declaration, we say abstraction. Means it's just an abstract idea that this class may contain a method called animal sound. Hence, to use it, you have to inherit this class, means extend it, inherit it, and then provide the actual definition of what this method needs to be. Because it's an abstract class, it does contain a regular method as well. To use it, you say we have a class lion, and then we extend the animal class. So now we need to extend this animal abstract class in a standard normal way, and we provide the definition of this abstract method. Okay, so we say public void animal sound, exactly following the same signature without the abstract word now. So actually we are overriding this method with our own definition. So that's why we say it's like a prototype. It's an abstract that provides that, hey, if I have a class, it needs to have these methods. The exact functionality is left out. It's dependent on the next person who is inheriting it and trying to figure out how I need to structure my code and what its purpose needs to be. So this is where abstraction comes into play. So when we create an object of that class, we use we call the function in a normal way. We call this method in a normal way. So I have a lion, I call this method, it does this task. Very simple as that. I can have my lion sleep. Now this lion does not contain the sleep method because it has been inherited from the parent, and this is a normal regular standard method. I don't need to override it. If I want to, polymorphism is there, but if I don't want to, directly just use it here. That's it. But then there's something called interfaces. Interfaces are complete abstraction. Okay, there are no regular standard methods allowed in an interface. Another way to achieve this abstraction is interfaces. An interface completely abstracts a class, and it's used for a full prototype model. And it's typically not a class itself. It's just like an abstraction, a complete detail of abstraction. That's why we don't use the word class anymore. We say it's an interface. There's no class word here. For abstract, we have an abstract class. For interfaces, we say, listen, this is something whole new ball game. It's a completely different thing. So what you need to do is you create interface, you create an animal, we define an abstract method. So all by default, all the data in an interface are abstract. So you don't need to use the abstract word here. In an abstract class, you need to use abstract method. So the method needs to have abstract word because it can contain the regular methods, right? So you need to differentiate. Because we are using an interface, it's supposed to be a prototype, it's supposed to be whole abstraction in a complete class, means everything has to be in an abstract form, not a complete detail form, just a definition form, declaration form, sorry. So There's no need for writing abstract here. We provide public void animal sound bracket star bracket close semicolon. We say public void sleep bracket star bracket close semicolon. The semicolon is important. There's no block of code here. The semicolon indicates this is an abstract method. This is an abstract method. Interface ends. So it provides a prototype that every animal needs to have an animal sound, animal sleep. Now, in order to use it, I have to use inherit it first of all. Okay, so I have to use it, and then in order to use it, I have to inherit it. But because this is not a class, this is an interface. There's no class keyword here. I cannot use the word extend because word extend is used for classes. Hence, a new word is used called implements. Implements means that I am implementing this abstract, and you can implement more than one abstract at any time. You can only extend one class, but you can implement more than one abstract. So to access these interface methods, we use this implement keyword. Then once you implement it, these methods become part of your code without definition. So you need to override them and provide their body definition. So public void animal name, the signature has to be exactly same. No arguments here, no arguments here. Block start, block close, and the body of the code is provided. Public void sleep, block start, block close, and then we provide a definition of this method. So now this implements means that we have created a lion from an abstraction of an animal. So we know that this lion will have a method called animal sound, performing its own individual task, sleep its own individual task. Similarly, I can have 10 different classes all inheriting or all implementing the animal, and they now we know that every animal will have these two methods, animal sound and sleep. So this is why the abstraction is important, because it defines a prototype model of what needs to be inside a code. Okay. Then to use it, we just use the object of this class. So we create another object, we access its methods like a normal one. Same animal sound, we call that animal sound here using myLion object. Simple as that. Okay. Last but not the least, we have something called Java exceptions. Okay. Java's OOP concepts and advanced Java concepts do not complete without the exceptions. Usually should be a little earlier in my understanding. Anyway, so what this exception means? Exception are what we call runtime errors. There are something called compile timers. So when we compile the code, if any logical, any spelling mistake, any syntax mistake is caught by compiler, but the logical errors are not caught by the compiler. They occur at a runtime. File not found, connection not established, divide by zero. These are what we call logical errors that occur at runtime. So if your system needs to connect to a database, but there's a connection problem, you get a runtime error, trung, pop-up message, right? So during running the code, it could perform certain actions perfectly, but at certain moment, it can create something called exception. So to handle an exception, a runtime error, we use something called try and catch statement. So those line of code that needs to have or that could generate an error, we put inside try and catch, so that if certain errors occur at a runtime, we can easily catch them and give the user a very meaningful blue screen of death. That's an example of exception. I mean, or we give them a very simple manner. Sorry, file not found. Cannot connect to the database. Connection not established. All those pop-up messages, errors that we get are basically generated through try and catch. So try and catch means if try this code, if it works fine, brilliant. But if there's an error, don't crash the program, don't shut down the code, don't go into the blue screen of death, kind of a phase. Give the user a nice message, bro, something is wrong, right? Or file not found, please select the correct file, the file name is invalid, file name is too long, connection not established. These kind of errors, they are handled by something called try and catch. So we write that line of code here. So idea again is there. You need to understand which code can generate runtime errors that are occurring at the runtime based on external or internal issues. So we write that code inside try, block start, block close, and then we use something called catch. Catch means that if the error occurs, don't crash the program, just catch it. And then we use an exception e argument There are tons of other exceptions that we can customize: array index out of bound, divide by zero, file not found, did connection errors. All these exceptions are subclass, but they all are basically subclass of exceptions. Okay, so we say exception E, and then we block start block close, and we use an error message that nicely identifies that, hey, something is wrong. Then we have something called finally, that is also part of try and catch. Finally is there, which means that as a default statement, if there is an error, execute the catch, execute the finally statement. If there is no error, still execute the finally. So whether there is an error or not, the finally block will always execute. So that's become important. So for example, file not found. What happens next? So finally will ensure that even if there is an error, instead of crashing a program, we write certain code here that handles and redirects or restarts our code automatically, so that a system it doesn't appear the system has crashed. Understand? So finally, in that sense, is very important. So if there is no error, still it will execute. If there is an error, still the finally block will execute. Okay, and then at a point you can throw your own exception as well. Okay, you can throw your own exception as well. How do we throw our own exception? For example, we use static void check age. We declare our own method, integer age. So if this method needs to have an argument, so we say if age is less than 18, throw new arithmetic exception access denied, and we write a string here. Now what we're doing, we're using a throw keyword to throw our own exception. And new, we know that is used to create an object, and this is the class arithmetic exception. It's by default present inside the exception classes. It's a part of exception class. So we are throwing this type of unique exception that, hey, if my age is less than 18, throw this error. So that way, when I write the code, for example, check my age, if my age is 15, this exception will be generated. Access denied, you must be at least 18 years or above. So this is again another unique way of handling errors. We could do this by if and else at certain points, but at a more advanced level, throws allows us to handle more profound runtime issues if they are occurring there. Okay. So this concludes the whole Java OOP session, ideally in 20 minutes, but I think we have exceeded the time. So I hope you liked it. Let me know this format. It's a quick tutorial to go through major concepts like breeze. So if you loved it, please leave a comment. If you hated it, please leave a comment so that I don't make these videos for all the courses. I stop making it. So I want a feedback from you guys. Okay. So if you love this, let me know and I will try to make more quick topics videos of that. If you don't love it, let me know. Hate it, crap, this is ridiculous. Please be open about it and I will stop making it. This is Dr. Shan Bhatting signing off.